We are taking question and answer on software quality assurance. What do you understand by black box and white box testing? Differentiate between them. So in black box testing, the internal structure, the internal code is not known to you. In white box, you are aware of how the code is written, what is inside. So the looping, the structure, the constructs, all is known to you. So black box testing, the implementation knowledge is not required because you are just going to check the functionality. In implementation, in the white box testing, the implementation knowledge is really required. Without that, you will not be able to do it. There are different names for black box testing. It is called closed box testing, data driven testing, and functional testing. Like this functional testing is used more than black box testing. Then white box testing, we have clear box testing, structural testing, and code based testing. In the black box testing, it is performed by even the user, because they can check the functionality, or software tester. But the white box testing, it is normally done by the software developer, because you need to know the code program, then only you can do it. Basis part testing, etc. So programming knowledge is not required in black box, and white box programming knowledge is required. So what are the types of testing which is there in black box testing? For example, you have a code. Now when you just write a code, you want it as a function. Now you will check it. That is, the input is going and output is coming. So you can call it as a module also, or a component also. So that is unit testing. So the black box testing and white box testing. Here when we combine the modules, different modules, so we check the interface testing. So this also comes under white box testing. So the unit testing, when you write a code, or module testing, or interfacing, that is the testing of interfacing, that also comes under the white box testing. So we have path testing, loop testing, conditional testing. This is all comes under the white box testing. But the low level testing is all what we call as white box testing, because you have to go to the code level and then you have to check. But you just have to check the function now. So if you are putting 2 and 3, if you want to check the add function, if 5 is coming, it's okay for you. So this is the functional testing. So functional testing, non-functional testing, and regression testing, they all comes under the black box testing. So these are the major differences between them. What do you understand about bug or defect triage in the context of quality assurance? Bug, defect, flaw, problem. In defect triage, the defect or the problem is reviewed. Then this defect is assessed. There is a proper assessment being done. And finally, we assign, say maybe resources we assign, like that. So defect triage is a method of prioritizing bugs based on the severity, the frequency with which it happens, the risk, and there are other factors also. So these are different factors on the basis of which the priority of these bugs or flaws are given. The term triage or triage is used in software testing and quality assurance to describe the severity and the importance of new fault. New fault has come, new bug has come, so we have to assign a number, we have to assign the severity. So in this software testing and quality assurance, we assign a severity and according to the importance. Now bug triage, the purpose is, as I said, just reviewing and prioritizing and then assigning the defect solutions to it. So team must confirm the severity of the fault, then need to make the certain changes, necessary changes, conclude the defect resolution, and then we assign the resources. So this kind of method or defect triage is normally used in agile project management. So depending upon the severity, the resources are assigned. So agile project management, we have to know the severity first. So the frequency of these defect triage meeting is also one of the aspects. It totally depends on the circumstances of the project. So what kind of circumstances a project may be in, then we have this meeting normally in the agile project management. So let me tell you the key elements of this meeting that influence the frequency of these defect triage meetings. First of all, maybe it is according to the product schedule or the number of flaws or problems or defects which are upcoming, and the impact on the availability of team members' schedules. Those who are those who have found out the error, those who are going to fix the error, and the state of the project as a whole. The project may be at the inception stage, it may be at the delivery stage, that is. What do you understand about stubs and drivers? Differentiate between them. So I'll give you a very naive way to understand it. We'll take an example also. But here, that you have say a module, there are 3 modules. Okay. Now one module is calling the other, and the second module is calling the third one. Now in case this module, the last module, is not yet being prepared, so we'll make a dummy program, and this program, dummy program, is called the stub. This is one scenario. Now this may happen that the main module which is calling the other modules, this is not developed. There may be circumstances. For that, we will make the driver program. So this driver is the main module. Stubs are the called module. So the stubs and drivers, mainly when we have sub modules for them, if they are not prepared, they are called stubs. But the major module, if it is not prepared and there are the low level modules are being created, then what we do? Then we have to make any module that will call them. So that is called the driver. Driver is the main program or main module. Stubs are the called modules. Okay. Please remember that we have a login, we have a home or a user. Now what happens here is the login is ready for the testing. The home and the user, these modules are not ready. So login module has to be tested, but without this home and user we cannot check. So for home and user we'll just write few line of code that will just emulate, mimic, and finally we will, once the testing is done, we will throw that code. Okay. I hope the driver and the stub code will eventually be thrown away. They are just written for testing. So stub, when we are doing the top-down testing, is required. When we are going for bottom-up, we require driver. So there are certain unforeseen circumstances where the high-level module or the module which is calling other modules is not prepared. The lower level modules are already being made. For that, we have to write the driver. Let us take this example again. So user and home are made now, but the login module is not yet prepared. So we have to write a simple code just mimicking or emulating this main module. That is called the driver. Stubs and driver. The difference between them is, let me tell you again, that there are modules at the higher level, there are modules at the lower level. So the lower modules are called by the higher modules, or the functions are called by the higher functions. So these are the sub modules. When the sub modules are, if the sub modules are not ready and we need them to be called in order to check the main module, for that we'll write stubs. Okay. We will not write any functionality. We will just try to write 2-3 lines just to emulate that, okay, this is being called. because we are eventually checking the main module. And similarly, when the main thing, the lower modules are ready, upper module is not ready, upper module will be called as driver when it is made. So top-down integration testing, stubs are employed. In bottom-up integration testing, drivers are used, and they are simple code which will be thrown away eventually. So we are just mimicking, we are just trying to write code so that the testing can be done. Stubs are analogous to software modules that are in the development stage, and drivers, they are not, these drivers are not, the stubs are not being made, right? They are just modules which are not being made. But drivers are accustomed to invoking the component that must be tested. So for that, we have to write a driver because it is calling modules, and those modules have to be checked. Okay. So these stub, they are also called as called programs. Stub are called programs or called modules or called functions. And driver is called as the calling program. You know the difference now. Calling program means it has to be above the lower level module. So it is calling program. And stubs are called. So that is called, they are called call program. Okay. To test the feature and functionality of the modules, stubs are used. If the core module of the software is not developed for testing for any reason, the drivers are used. So whatever I have told you is all about the upper level module and lower level module. Upper level module is completed, lower level module are not completed, you have to make stub. Otherwise, you have to make driver. What is the rule of a test driven development? So in the test driven development, what we generally do, we write the code and then we test. So in between, we may write the test cases. The cyclomatic complexity we compute, that gives the upper bound of the number of test cases. So then we just write the test code and test cases, and then we test. In the test driven development, the things are different. Before even writing the actual code, we prepare the test cases. The only difference is that the test cases are prepared before, written before writing the actual code in the test driven development. For example, if a code, you know already that these are the passing parameters. You already know that these are the acceptance testing scenario. So when you know that these are kind of a test we have to pass, so we make the test cases earlier, before making the code, because we will make the code in accordance with these test cases so that we can pass the final test cases. So we write the test cases, execute the test cases. If the test case fails, then the changes are made to make it correct, and then we repeat the process. This is the TDDC, test driven development cycle. What is ad hoc testing? Ad hoc means, for example, in your college, there are certain teachers who are, or professors which are permanent. There are someone who are just, you can say, called in agreement or contractual basis. They are ad hoc. So you can relate with that. Ad hoc testing is an informal way of testing. That means it has no formal way. In a formal way, we will first write the SRS, then design, then we write the test strategy will be defined, test plan will be defined, test cases will be written. All this is a formal way. But in ad hoc testing, there is no formal way, no requirement documents, no test plans, no test cases. So the characteristics of ad hoc testing is performed after all the formal testing is done, because our main aim is to break the software by any means. Ad hoc means doing everything which is possible. So the testers who are executing the ad hoc testing, they should have a deep knowledge of the product. So even you can give it to a naive also, because no documentation, no test design, no test case, anyone can check. You just have to break the system. How is ad hoc testing different from exploratory testing? See, exploratory testing is learning testing. In ad hoc testing, you test in order to break the system or a software. After all the testing is done, exploratory testing is starting from the scratch and trying to learn the software by testing. So in ad hoc testing is the testing of software without any documentation or requirement specification. Exploratory testing, the knowledge about the software while exploring the application. That is step by step, you learn the software while testing. Because when we go on a way and we don't know the path, we just say we are exploring. So we learn the software by means of this testing, and that is called the exploratory testing. You are finding the ways by yourself. So ad hoc testing, I told you that there is no, because it is informal. So documentation is not required. Exploratory testing, documentation is mandatory. Ad hoc testing, the main aim of ad hoc testing is to achieve the perfection in testing, because all the other testing has already been done. Now you are doing everything to break the software. So you are trying to achieve the perfection in testing. Okay, we do everything which is possible. We need to crash or break the software. In exploratory testing, the main idea is to learn the application, to understand the application, to gain knowledge about what is happening by the means of testing. Ad hoc testing is an informal approach, but exploratory testing is totally formal approach, because we are stepwise learning through testing. Ad hoc testing does not require an expert testing engineer, as I said. That is, whatever you want to give, you give. This is ad hoc. Because maybe some click or some combination of keys can break your software. Exploratory testing does not require an expert testing engineer. Because even if you are, because this is a learning curve. Anybody can do this exploratory testing. It is just learning about what is happening in the software through testing. So this is the difference between ad hoc and exploratory testing. That is, okay, this is the way exploratory is. This is the way. Oh, from here, oh, this is the new way. So we start learning. What are the different levels of software testing? See, software testing, there are two types of software testing: functional testing, non-functional testing. But when we are talking about levels, say you have started writing code just now. You will write 4 or 5 lines, or maybe 10 lines or 40 lines in a day. So let us say that you have these 40 lines is a function. So you will check these function, that is the unit testing. Now next day you wrote one more function, or you can say 2 modules are being made in few days. Now you are combining them, and that combination and then checking, that is called integration testing. Now you have created all the modules, the software is ready. Now it has to be checked with all the other systems which are working with your software system. That is called the system testing. Actual testing after the system is actually being created. And finally, the user will test. That is called the acceptance testing. Alpha and beta testing. This kind of testings are acceptance testing. So there are 4 different levels in software testing: unit, component testing, integration testing, system testing, and acceptance testing. Unit testing. So as I said, this is the lowest level in the testing level, lowest level. Unit can be even programs, even can be modules or the components, and because they have to give certain result. Unit testing is performed by the programmer because he knows about the modules, he has written the module, and any function, any problem is there, he will fix instantaneously. So once the unit testing is done, we go for integration testing, because now the modules are being created, few modules, and now you combine them. So we have to see the interfacing, that how this integration testing is all about how the data is flowing from one module to another. So collaboration, interdependency, interface testing. So we are checking the communication between multiple modules. We don't check the functionality of individual modules. That is done in unit testing. So this is the integration testing. Then the system is finally complete. So system testing is used to test the complete or integrated system. So it is basically related to SRS, software requirement specification, that all the all the requirements are being completed, and this is the system testing. And as I said, both functional and non-functional testing is performed as a part of system testing. And finally is the acceptance testing, and this is performed by the users or the stakeholder, the customer. Now I'll tell you alpha and beta testing here. The difference, just see the difference. See, if alpha testing, beta testing, see, first of all, alpha testing is that you are going to the developer place, because developer is controlling the environment now, and you are testing your code, your software. That is called the alpha testing. Now the software is tested at your end, at your environment. The developer has no control over this environment. That is called the beta testing. What do you mean by quality audit in the context of quality assurance? So quality audit, see, audit is all about checking, verifying, and inspection, examination. Just say you have a company, you have a balance sheet, and then some money you sell, some product you sold, some product you buy. There is a whole dollar amount which you know. Now, if your company is big, how to know that things are going fine? No forged bill is produced, like that. Money is going every good way, or the income tax is being filed. So for that, audit is done. So same way, in order to ensure the quality audit is done. So there will be an audit is an on-site verification activity of a processor quality system, like the inspection or examination. It can be an internal or an external quality auditor, or even can an audit team can be there. It conducts a systematic analysis of quality system as a part of quality audit under quality assurance. So quality audits are conducted at predetermined intervals to ensure that the institutional internal system monitoring methods are well defined and linked to successful action. So audits are an important management tool for confirming objective proof of processes for quality assurance, quality control, and the testing. So any problem will come out. For this, quality audit, all the process is basically producing a report that things are not followed and you need to work on it. So in order to ensure quality assurance, we need to seriously take the quality audit report. Okay, let me tell you in another way also. Let me clean it. See, quality audit is verification effort aimed at determining the degree of compliance of a product, design, or a process or a system to a standard specification or procedure which is already defined in quality assurance. So the quality audit includes two parts. The first is the examination of the system, in which the product or services are created, known as the quality system audit. The other is a product or service quality audit, which is examination of product themselves. The first is the product and services, that is the processes. Second is actually checking the product or the service, means actual examination. Okay, this is all about this discussion. Thank you so much.